Deep below the surface of Sri Lanka lies a tunnel 25 feet in diameter, spanning 17 miles, being dug by this. A custom 1,400-ton machine nearly 600 feet long, and its goal is to alleviate suffering for tens of thousands. Severe drought is common in Sri Lanka's northern region. Saltwater is seeping into wells. Groundwater is unsafe. Farms are dying out, and families are struggling. The solution? Two of the most powerful machines on Earth, made just for this. Sri Lanka's north-central province is home to over 1.4 million people, yet it continues to face devastating drought. The province lies almost entirely within the country's dry zone, which receives over 60 inches less rainfall each year than the lush wet zone in the southwest. Families in this region often have to walk miles for drinking water.
වෙනදා සාමාන්‍යයෙන් අපි තුම්බේලම බත්තු යාගෙන කෑවා. දැන් එහෙම කන්න අපහසුයි.
And buying water isn't always an option. The average farmer makes the equivalent of $2,600 a year. For decades, leaders debated options to help these communities. They could build canals, but they'd slice through villages. Dams would drown farmland. Channels threaten wildlife and forests. All of the options posed new problems. Every season without action meant more hunger, more poverty, more disease. Sri Lanka needed to go underground. A tunnel could move massive volumes of water without destroying communities or ecosystems, and it could move that water fast. But ordinary excavators, drills, or blasting techniques would take decades to carve through the earth, and far too often pose dangers to workers.
We used to excavate tunnel. In previous, we used a drill and blasting method, which is very dangerous, and it will cause severe harm to both people and the environment.
Sri Lanka needed a tunnel boring machine. You might have heard about these machines from Elon Musk's venture into tunneling with the Boring Company, or Bertha, the TBM that dug a massive tunnel for a highway in Seattle, or even the biggest tunnel in the world, the Gotthard-based tunnel in Switzerland. Colossal, precise, relentless. These machines are capable of cutting through the hardest rock while building a tunnel as they go.
It is very difficult to understand the full scale of this machine. It's like a factory.
They are helping to build 17.4 miles of the Maha Ella irrigation project, a projected 59.6-mile system designed to carry water from the rainy south to the parched north. Two custom-built TBMs were ordered from China. The journey was an engineering feat itself. Workers transported 1,300 tons of equipment across oceans and over 15,500 miles of roads and bridges to reach the remote launch site. Both machines had to be transported in pieces and reassembled on site. But even disassembled, bridges had to be widened and reinforced to fit the massive machines.
Since the machine is heavyweight, we have to use the heaviest crane we operated in the Sri Lanka. That is how we installed this machine.
Planning for the project started in 2018, and in January 2023, the machines broke ground. Each cutter head is 25 feet in diameter, lined with more than 200 discs made of tungsten carbide, a chemical compound that's one of the hardest materials on the planet, second only to diamonds. These discs grind through solid rock at up to 11 revolutions per minute, while water and air jets cool and clear debris. Conveyor belts carry thousands of cubic feet of broken rock out of the tunnel every day. Hydraulic erectors place precast concrete rings immediately behind the cutter head, forming a structurally sound tunnel. Sensors detect unstable layers. Engineers continuously track alignment, curvature, and geotechnical data to maintain a precise course. The TBMs are effectively mobile factories, excavating rock at the front while installing the tunnel lining behind. And they had to be custom built for a reason. Sri Lanka's terrain is unforgiving. The earth the TBMs are digging through is made up of different soils, rocks, and water pockets, so the machines need to be ready to adapt. The cutter heads can be equipped with different tools, depending on whether they hit soft or hard deposits of rock. The engineers also have the option of using single or double shield mode. Double shield tunnel boring machines can bore a hole and install the tunnel lining simultaneously to keep unstable earth in place. In contrast, single shield mode prioritizes precise cutting without automatic lining installation, giving crews more control when dealing with unstable or waterlogged sections.
If there is kind of cavities or water or weather section present, we can pre-identify that kind of features.
But sometimes the ground can change suddenly and create dangerous conditions for workers. There are reports that Sri Lankan workers faced abuse, long hours, harsh conditions. But the Sri Lanka TBMs precast concrete rings, so workers never enter unstable zones, and its sensors and steel shields have helped keep the crew safe during the project. As of autumn 2025, one TBM, launched in December 2022, has made it over 9 miles. The other, launched in November of 2023, has drilled over 4 miles. The project is expected to be finished in 2026. It can't come fast enough. Northern Sri Lanka's dry zone faces severe water stress, leaving tens of thousands in seasonal scarcity. The Maha Ella irrigation project could flip the script. If the plan works, its 17-mile tunnel will move 132 billion gallons of water each year through a 60-mile canal network. It will hopefully fill 1,505 village tanks, irrigate 182,000 acres of farmland, and directly support 100,000 families, digging a combined 273 feet a day. These TBMs promise life-saving relief, food security, clean water, and resilience to a region desperate for solutions. The lesson is clear. When humanity faces limits above ground, we go below. With drought spreading, populations booming, and cities swelling, tunneling doesn't seem like an option. It seems essential for irrigation, flood control, power grids, and even underground living. TBMs keep getting smarter and faster, making safe tunneling a reality. Maha Ella shows what is possible when necessity and ingenuity meet. And it reminds us that the future may be built beneath our feet.